Welcome back, Pre-Calc. Our objective today is going to be to apply matrix operations. I've got the checklist on the screen. You know what to do from here. First, pause on the screen. Can you copy matrix A in your notes, please? Okay, so we are going to look at some basic operations on matrices today. A matrix is basically just a string of numbers, and the order or the dimension is said to be the number of rows by the number of columns. So how many rows does matrix A have? It's got 1, 2, 3. And how many columns? It's got 3 columns as well. So we say that the order of matrix A is a 3 by, do a little x, 3, okay? And then it says it's matrix A square. Well, square means that then your number of rows is the same as your number of columns. So in this case, yes. Now what is element A sub 2, 3? So 2 is what row you're on, 3 is what column you're on. So I'm going to go second row, so that'd be this row, third column, which would be right here. So second row, third column leads me to element A sub 2, 3, and that's going to be -1. Now, let's say I want to find 3 times A. All that means is I'm going to multiply a 3 to every single element in this matrix. So my new matrix, my first row, instead of being 2, 2, 4, if I multiply 3's to all of that, will be 6, 6, 12, right? Multiplying a 3 to row 2 will be -9, 0, -3, and that final row is going to be 6, 3, 6. So literally think of just distributing a 3 to every single element there. First, pause on the screen. Can you copy the 2 matrices you see there, matrix A and matrix B? All right, we are back. So if I want to do matrix addition, like if I want to take matrix A plus 3 times matrix B, well, we just saw how to find 3B. I'm just going to distribute a 3 to every single term here. So for example, my new row 1 here, instead of 2, 0, 0, if I multiply 3's to all of that, will be 6, 0, 0, right? And we can keep going with the other rows. Now, if I want to add 2 matrices, the orders have to be the same. So what is the order of matrix A? Matrix A is a 3 by 3. I'm just going to put a little notation here, 3 by 3. And that's the same order as matrix B. Since those are the same, I can add them. Okay? If they're not the same orders, good news for us, we can just say it doesn't work and move on to the next problem. All right, well in this case it works, so I'm literally just going to take element 1, 1 plus my new element 1, 1, like I've already distributed a 3 here, right? So I'm just going to take 2 plus 6, which is 8, and then this 2 plus this 0, which is 2, and then this 4 plus this 0, which is 4. Okay, can you go ahead and finish up the last 2 rows? Make sure you distribute a 3 to every element in B, since we did want to do A plus 3B. Hit continue when you're ready to check your answer. All right, answers on the screen. If you need to correct anything, do so now. All right, so scalar multiplication and matrix addition, very straightforward, pretty much exactly what you would think. Matrix multiplication is a bit different. We don't go element by element. It's got a different spin to it. This is for application purposes, particularly with vectors. So we're going to do a little bit of practice. If for matrix multiplication, you do still need to check the order of your 2 matrices. So let's call this matrix A. What would you say the order is on matrix A? This is a 2 by 3. Okay, what would you say the order is? Let's call this matrix B. This is a 3 by 2, 3 rows, 2 columns. Notice they're not the same order, which is actually not necessary for matrix multiplication. What's necessary is that your number of columns for your first matrix matches your number of rows for your second matrix. That's all we need, okay? And then my new matrix is going to be this number, my number of rows for matrix A, by my number of columns for matrix B. So what will my new matrix order be? It's going to be a 2 by 2, okay? All right, I'm clear. So force pause on your screen. I'd like for you to write the matrices exactly as I have them here. So matrix A, I'm going to kind of stack to the left and down. Matrix B, I'm going to stack to the right and up. Okay, so copy exactly as I have it because I've stacked them like this on purpose. Hit continue when you are ready to work this one together. All right, so the first thing we're going to do is write our new matrix. So I've got a attempt to do this here. These vertical lines are very difficult on this tablet. Okay, so we said it's going to be a 2 by 2, so I'm going to go 2 rows and 2 columns, okay? And I've stacked them again. I've stacked them on purpose because for this element here, A sub 1, 1, I'm going to take my first row, elements from my first row, times elements from my first column in the second matrix. Here's what I mean. I'm going to work my way in. So start here and here. So I'm taking 1 times negative 1. So let's write this to the side. Then you're going to work your way in, and you're going to use addition in between. So working my way in, now I'm at 2. Okay, so I'm going to do 2, working my way in here. In other words, going down, I'm at 0. So I'm going 2 times 0 plus 1 more, keep working your way in, 3 times, come to your column here, work your way down, 1. Okay, so I've got negative 1 plus 0 plus 3, that's going to be 2, and that is my first element right there. Okay, so notice this is element A sub 1, 1, so I went first row here times my first column here, and I just literally worked my way in, adding those products together. Okay, it's a little different, so let's try one more. Or a couple more. Let's now go to this element, okay? This is still row 1, so I'm still going to be using this row, but now I'm in column 2, so I need that column, okay? So start on the outside and work your way in. I'm going to go 1 times 2 plus 2 times negative 1. Plus 3 times 0. This is 2 minus 2 plus 0. I'm getting 0 there. Okay? Color coding helps. All right, let's look at this element. This is from the second row, first column. So just look at where it's coming from. This row, this column. Right? So start on the outside, work your way in. 4 times negative 1 plus 5 times 0 plus 6 times 1. So I'm getting negative 4 plus 0 plus 6. That's going to be positive 2 there. All right, let's do that last element. Look at where it's coming from. Second row, second column. Okay, so start on the outside, work your way in. 4 times 2 plus 5 times negative 1 plus 6 times 0. So I'm getting 8 minus 5 plus 0, which is 3. And there is my new matrix with order what again? 2 by 2. Very good. Force pause on the screen, go ahead and copy the 2 matrices and do them, stack them how we did it earlier. So stack them appropriately, A kind of jutting out to the left and B on top. Go ahead and hit continue when you're ready to work this one together. All right, so order is going to matter here. Make sure that A is on the left and B is on the top. Okay, so what is the order of matrix A? A is a 2 by 3. And what's the order of matrix B? B is a 3 by 2. So is matrix multiplication possible here? It is, because the number of columns for matrix A matches the number of rows in matrix B. So what is the order of my new matrix? It's going to be a 2 by 2. So let's go ahead and draw that. So let's see how we do here. All right, 1, 2, 3, 4 elements, right? Okay, so let's try that first element. I need first row from A and first column from B. So I'm going to work my way in. 1 times 2 plus 5 times -1 plus 2 times 0. Which is going to be 2 minus 5 plus 0, so -3. Okay, see if you can finish it up on your own. Hit continue when you're ready to check your answer. All right, I've got the answer on the screen. Correct anything you need, pause and correct anything you need to. Okay, so let's say I give you the same matrices and this time ask you to find B times A. So let's take a look at these. What is the order this time of this matrix? Again, this is a 3 by 2. And what is the order of this matrix? This is a 2 by 3. So is matrix multiplication possible here? It is, because your inner numbers match, right? Now, what will the order of my new matrix be? Can you tell? It is going to be a 3 by 3. So I'm going to have 1, 2, 3, 4, 5, 6, 7, 8, 9 elements. So, for example, to get this very first element, I'm going to take first row here times first column here, so 2 times 1 plus -1 times 5. That would give me a -3 here. We're not going to fill it all out. I just want to show you that, am I going to get the same matrix here, multiplying B times A, as I did over here, multiplying A times B? Definitely not. They're not even the same order, right? So this is very essential to matrix operations, is that matrix multiplication is not commutative. In other words, A times B is not the same as B times A, which is much different from what we're used to with real numbers, right? Like 2 times 3 is going to be the same as 3 times 2. Not the case for matrices, okay? Order matters when you multiply matrices together. All right, that said, let's do a little bit of review with matrix multiplication and their orders. Can I multiply a 2 by 3 times a 3 by 2? I can, because the insides match, right? What would my new matrix be? What dimension? It would be a 2 by 2, so it would have 4 elements in it, all right? Can I multiply a 3 by 2 times a 2 by 3? Again, I can, because the insides match. The number of columns for this matrix matches the number of rows for this matrix. What would my new matrix be? It would be a 3 by 3, okay? Okay, so for real numbers A and B, they're said to be inverses of each other, or reciprocals. If, when I multiply them together, I get 1, right? We have an analogous situation for matrices, okay? So matrix A and matrix B are inverses of each other if, when I multiply them together, either way, I get this matrix I, where I is considered to be your identity matrix. So for a 2 by 2, you would have 1s in your diagonal, 0s everywhere else, okay? If I had a 3 by 3, this is what my identity would look like for a 3 by 3. I'd have 1s in my diagonals, 0s everywhere else. Okay, so why do I care so much about these identity matrices? Well, if I take a matrix times an identity, I should get my original matrix back. Let's try an example. Okay, first pause on the screen. Go ahead and copy what I have. I have one matrix, 1, 2, 3, 4, times the 2 by 2 identity, 1, 0, 0, 1, and let's figure out what our answer would be here. So I'm first pause on the screen, hit continue when you're ready to do this one together. Okay, so let's say I want to find this element. I would go first row here times first column here. So I'd go 1 times 1 plus 2 times 0, right? That is going to be 1, okay? Finish the rest, hit continue when you're ready to check your answer. Okay, we should have gotten exactly what we started with, 1, 2, 3, 4 again, because this identity matrix acts basically like 1 does with the real numbers. So any square matrix times the appropriate square identity gets you back to your original matrix. All right, you all, that is all we have for today. I will see you next time.